electric generators basically work in an opposite way to that of electric motors, in a sense that in an electric motor, basically you use electricity to disturb the magnetic field and that creates motion, right? Now, in an electric generator, you basically do quite the opposite. You use motion to disturb the magnets or the magnetic field basically, and this creates electricity in the coil. It's really quite fascinating how Faraday described this electromagnetic induction in such a way that if you take a couple of magnets and move it around a coil, then basically the magnetic field changes and that induces current in the coil. You can see the arrangement here with the slip rings, magnets and brushes, and the interesting part is that if you connect this coil to a voltmeter and observe now as the coil spins, the voltage goes positive, negative, and it flickers around every rotation. This means the current is maximum at one point, which is in the coil's first quarter of rotation, then the current goes down. Then it goes in the other direction to reach its minimum point, then reaches to zero again. As you can see here on this graph, the current is basically alternating between positive and negative. And this is what we call as alternating current. But the problem here is, we can't use this AC or alternating current for our everyday electricity purposes. We need to change this AC into DC, which is direct current, which doesn't have any fluctuations. To do this, there are a lot of ways, but usually a lot of generators use a switch that basically changes the polarity of the coil when it comes to the other side. As you can see here in the graph, as the coil reaches the point 0, its polarity is changed and again the fluctuation is negated. So what have we learned in this video? We have seen how electric generators work and also what is alternating current and direct current. So until next time, happy learning!